Good afternoon, dear participant of 89th course on basics of geocomputation and geo-web services and the fourth module of 85th IRS outreach program on basics of remote sensing, GIS, GNS technology and its applications. So I welcome you for the first session of this particular course. My name is Harish Karnatak. So I'll be briefing you first about the course contents, and then I will be delivering my first session today on the basics or introduction to geocomputation and geo-web services. Dear participant, this course is basically having around 11th session, and this session will be conducting every day 4 o'clock. The exact time is 4 o'clock. 4 to 5 will have the live session, and 5 to 5:30 will be conducting the interactive session. During the interactive sessions, you can ask your questions through the chat box of the e-class platform. You have to log into the e-class, then you can join the session. If you are a registered participant, then you will have a particular link there to receive the live session, plus you will also have the link to ask your question as a chat box through the chat box. So in this particular course, we'll be having the session on the geocomputation and geo-web services, which will be delivered by me. I'll be talking about the technological aspect and also some of the popular application of the geocomputation. Then our second session will be on geodata repository and ISRO geo-web services for thematic applications. So this particular session basically will be talking about different data repositories with respect to GIS data, and we'll be focusing more on the ISRO Bhuvan Geo portal, and we'll also showcase you the various thematic applications what you can build on top of the GIS data sets. We'll have a technical session on the programming concept for geocomputations. Today first we'll understand what is geocomputations, and then the first session on the programming part will be based on the Python language. Since it is a very short course, we are not going into detail of the Python programming language, but we'll be giving you introductions how you can use the Python for geocomputation purpose. And this session will be delivered by our colleague Mr. Ravi Bhandari. And then we'll be having a session on database management system, relational database management system, and a special database management system for geodata handling. If you are a student of the computer science or IT, you may be knowing that the concept of DBMS, RDBMS and SDBMS is basically being used for the data management purpose. And there are many open source and commercial softwares or platforms for DBMS. Here what we will discuss about is how you can handle, how you can store and manage the Raster vector data, and how you can perform SQL queries, especially for this geodata. So this session will be delivered by my colleague Mr. Dharmen Kumar. Then next session will be on the programming concept for geocomputation using R. I hope you may be knowing about the R programming language, which is a very powerful tool or platform basically for data science related activities. So in this particular session, what we'll be discussing about the how you can use the R libraries basically to handle the geo data to solve any computation problem. So Mr. Kamal Pandey and Mr. Ravi Bhandari both will be taking this session. Then we'll have the session on the web GIS, that is basically in the web platforms or internet platform, how you can use geodata, how you can use this platform basically to visualize the 2D and 3D data, plus for data analytics purpose, how you can use the online applications or online programming languages to build the interesting application for the users. So that will be taken care by Mr. Kamal Pandey. And then we'll have a session on the cloud GIS. You may be knowing about the cloud computing concept that is also getting very popular these days. You know that when we have the smart mobile phones, we have the low-end computer devices like laptop and simple desktops. Sometimes these devices are not sufficient to handle the GIS data when you have very large amount of data or we have the very complex data structures or unstructured data in place, that time the normal computation devices are not sufficient to handle this data. So then we will try to understand how the cloud computation platform can solve this particular problem of data handling, and then we'll also show you the practical demonstration how you can use the cloud for geodata handling, and this session will be delivered by my colleague Mr. Ravi Bhandari. So this is the overall structure of the course, and next maybe 1 week time we'll be discussing these technical topics, and I request all of the participants to be very interactive, ask your doubts, questions to the experts, so that we'll have a very interactive kind of sessions. So now I will start my today's session, that is on the introduction to geocomputation, online GIS and Geo-web services. Last year we have conducted 2 particular sessions on these 2 topics, but this year we have little bit time constraint. That's why we have clubbed these 2 topics in one session. So I'll be discussing about the basic concept of geocomputations. Basically here we'll be talking about the computation challenges when you are dealing with the geospatial data. You may be knowing about normal attribute data, textual data, or sometimes some imagery data like a photograph, sometimes video also, or multimedia data as well. But geospatial data, when I say it is basically a raster and the vector data what we handle in the GIS environment. But if you are a computer student or IT background person, so you have to understand how you can write a program for this data and what are the computation challenges to deal with the geographical data. So today I'll be just discussing about the basic challenges with respect to computation challenges. I will talk about it. So then we will see what is exactly the geocomputation. So if you see the definition of this term geocomputations, it is basically defined as the art and science of solving complex spatial problem with the computers. So when I say the spatial problem, that means I am talking about the location specific problems. So when I say the location specific problems, so next question is how I am going to define the location. So in GIS, in the module 1 and module 2 and module 3, in all the modules we discuss about the location data, that is basically in terms of coordinate, and these coordinates are x, y, z. That is a latitude, longitude and altitude. When we present the location in this form of mathematics, then we call it a geolocations, or when the data is related to the geolocation, that it is called geodata. And when we use the computers to handle this data to solve any specific geographical problem, then we call it a geocomputation problems. So basically you are utilizing the computer systems to solve a spatial problems, that is a location specific problem. The process of applying computing technology to geographical problems, this is another definition where you can say that the geocomputation is a process of applying the computing technology to a geographical problems. And if you see the next definition says that the computational theory of a complex social temporal processes. It's very interesting, socio-temporal processes. That means in this geocomputation domain, when you handle the data, that data is basically a time series or temporal data. That means in due course of time, the data is changing. When I say the due course of time, the data is changing, these changes are very important to understand the patterns and trend in the geography, and this kind of data also you can handle or you can address by using the geocomputation techniques. So geocomputation is the way in which new computational tools and methods are used, also functionally about the depiction of spatial processes. This is another definition given by the researchers in the 1998. Now in nutshell, what we can say that geocomputation is a method to use computations for processing and analyzing geographical data for information extraction and decision making. These are the 2 important keywords what you have to remember. So why we are doing this computation intensive activities on this geodata is basically for extraction of the information from this data. This is point number 1. Second is why we are extracting this information or knowledge from this data is basically for better planning and decision making. So basically what you have to say that the geocomputation is a method to use the computations math processes for information extraction and knowledge discovery from the database for better decision making and planning activities. Now, if you see the historical view of this geocomputation definition, the Sten Openshaw is generally recognized as the father of geocomputation, and he stated that geocomputation is about the various different type of geodata and about developing the relevant geo tools within the overall context of scientific approach. So when you are handling the geodata or geographical data using your computer systems, so basically he says that we are talking about the scientific approach. So scientifically how we are going to understand this data, how we are going to understand this information for better planning and decision making. He defined three aspects of that makes geocomputation special. First thing he told that the geo is a keyword, geo is a subject, that is a geocomputation is concerned with the geographical or spatial information. This is point number one, or you can say this is one of the important characteristics of the geocomputation is it is referring or it is talking about the geo. Geo, here you can see the term very nicely it is defined. Second important characteristics of this geocomputation is the intensity of computation. Intensity of the computation required is distinctive. So here it allows new or better solution to be found for existing problem and also let us solve problem. It is basically a problem solving environment for using the intensive computer system, so all computer processes. Third characteristic, it says that geocomputation require a unique mindset because it is based on replacing vast amount of computation as substitute for missing knowledge or theory and even the augment intelligence. So here it says that geocomputation require a unique mindset. When you are dealing with the geographical data, it is not all about simply writing the queries or SQL statements or simply writing the algorithm of this data. So here it says that it is a very, very important skill set what you required here. You have to understand the geography because these data sets or the informations or decisions are location specific. So when you are dealing with this kind of data, you should have some prior knowledge of the actual reality in the real world environments so that you can play or you can work around this data more intelligent way so that better information can be extracted from here. These are the three important characteristics what you have to keep in mind. So in what context basically we are talking in the geocomputations? So the four questions to be most important with respect to definition given by Sten Openshaw are: is there a focus on the high performance computing? So then now these are the questions what you can ask there. Either in the geocomputation, are we only focusing on the high performance computing or HPC kind of platforms? Is geocomputation simply a grab bag of tools? What is the relationship between GIS and geocomputations? What are the key concepts of geocomputation? These are the basic four questions what we are going to discuss today. So basically it is not all about the only SPC or high performance computing environment. Generally what people are doing these days in the high performance computing clusters, lot of computation infrastructures with respect to processing capabilities, with respect to memory, with respect to storage are available. But you cannot say that when you have this kind of infrastructure in place, you are working on the geocomputation platform. It is one of the characteristics, but not only characteristic of the geocomputation activities. Now, before going to the geocomputations, you should understand what this geodata is. So you know that in the first module, in the remote sensing module, second in the GIS and GNSS modules, what we discussed there, we discussed most of the time different techniques of Earth observation systems. We discuss about the sensors, then we discuss about the different type of data or information what we are extracting in the form of the raster data models and vector data model. But as a computer science students, if you try to understand what are these raster and vector data, what are this attribute data, so how we are handling this data and how I define this data as a geodata. So first you have to understand the spatial database is a database that is optimized to store and query data that is related to object in space, including point, line, and polygon. So here the keyword is the data that is related to object in a space. Object in a space, when I say that, that means I am using three major geometries. These geometries are point geometry, line geometry, and polygon geometry. When I use these basic geometry to represent the different geographical phenomena in a computer system, then I say that it is a data model. So for example, if you are selecting vector data model for representing a line or a road features, a geographical feature is a road, and this road basically when you are presenting into the computer system, then you are generally using the line features. So line geometry, that means the road is represented as a line. That means the line will have at least 2 points, x1 comma y1, and second is x2 comma y2. So this is just a data model, but in reality the always roads are not line. Roads, if you see, road will have its width and length both. That means you can also represent road as a polygon. But when you are representing road as a polygons, then you will have the certain limitation with respect to computations. When you suppose you are interested to perform the measurement of length, or you are interested to do some network analysis there. So in case of polygons, so GIS systems may not allow you to do the network analysis. That's why you are presenting road as a line in your database system. So these are the data models. These are not actual. So that means when I representing my reality into the computer system, I have some inbuilt uncertainty in my database. So that uncertainty you have to keep in mind. So definitely when you have a simple line features, the measurement of length is more than sufficient. But what about the width of the road? How I am going to store it in the computer system? Because if it is a line geometry, that means line geometry is not capable to store the complete information about the road. Same way will be applicable for point and polygon as well. So here you have to understand. So line, when I am drawing or I am storing into computer system, that means it is very good to do my network analysis. It is very good to do my measurement, like length measurement of the road networks. But the width of the road or traffic movement, either it is a one-way traffic or two-way traffic, this information also I will be storing into my database as a characteristics of that road. So when I say the characteristics of this road, that means this information I can easily store into a non-spatial data or a attribute data. So this way, if I link this attribute data and spatial geometry together, then I will have the complete database with me, and then I can analyze this data better way. I hope you are understanding this point. This is very, very important. Only drawing line on top of the satellite imagery or drawing a line in a GIS software is not sufficient, because the characteristics or attributes are very, very important. So here what you have to understand, when we are dealing with vector data models, we use three basic geometries, point, line, and polygon, to represent our geographical feature into the computer system. The another data model which is very popular is called raster data model, where we use the pixel, that is called picture element, basically to represent or to store the information in a computer system. So while typical databases can understand various numeric and character types of data in database system, for example, if you take the example of MySQL, you take the example of Oracle, you take example of MS SQL Server, you know that there we have the standard data types like numbers, integers, characters, varchar, varchar2. So these are the some or date, times, blob, clob in the Oracle. So what these are the basically data types. But these data types can store a normal database, a standard database. But typically here we have to store the geometry of a geographical feature as well into database system. So the geometry is making this data as a unique data. So these are the typically called geometry or features, and these are also need to be stored. Now if you are a computer science students, then you can ask the simple questions, which data type will be suitable for vector and raster data, because here it is not only storing the values or characteristics or attribute of the data, but here I am talking about the geometry. So in the RDBMS, when we have the limited number of data types, then how I will store the geometry? Geometry means point, line, polygons. When I have the geometry, that means I also need to store not only the data but also the different type of operation that can be performed on these data sets. What does it mean? Suppose I am storing a point, then I have to define in my RDBMS that with this point, what kind of operation you can perform. Because in case of line, you can do the measurement of length, but you cannot do the measurement of area in the line. So these rules also I have to define into my database system. So that you have to keep in mind. Second important point, suppose you are storing this data into your SQL or structured query language, you are storing in database management system, and you are interested to use a structured query language to perform different type of analysis with this data, or you want to use some different DML or DDL or DCL statement like select, create statements, or maybe some conditional statement. So to perform a wide range of special operations, like suppose you are interested to fire SQL queries for the spatial measurements, like find the distance between 2 points or measure the area of a polygons. So this could be a one type of query, because when you are storing this data into RDBMS. Second is the spatial functions. So like spatial function could be a modify existing feature to create a new one. For example, by providing a buffer around them, intersecting the features. Suppose you have a line and you are interested to create a buffer or a proximity of 100 meters in your road. Then can I create a new features by applying this buffer to apply this proximity on this particular line features? This is called this can be considered as a spatial function. Then next special characteristics what I required is a special predicates, like allow true or false queries such as is there a residence located within a mile or within a kilometer of the area we are planning to build a landfill. Suppose you are interested to build any commercial centers and you want fire queries. So is there anything, or how is there any residential area within 1 kilometer of this particular point? So this can be a very simple Boolean operator or Boolean operation in the database management system. But how I will do it? How the SQL will help me to basically perform this kind of analysis. Next important characteristics of geodata is basically I should have a constructor function. Constructor function means to create a new feature with an SQL query specifying the vertices, point of nodes, which can make upline. If the first and last vertices of lines are identical, the feature can also be type of polygons. So that means it is a constructor function. When I am storing the different type of coordinate like x1, y1, x2, y2, and x3, y3. So now if I combine these all three coordinate together, is it can I create a line? Can I create a polygons or some other feature? So here I should have this kind of constructor function, because when you are storing a polygon or line into database system, it will not be exactly a point or line. It will store as a simple point. Only x, y. The database system can store only x, y, but only you can construct the sum of the geographical features, some of the geometries like line and polygons by applying the constructor function. This is another important characteristic, or this is another important power what I required in my database management system. Then next important characteristics is the observer functions, that queries which returns specific information about features such as the location of the center of the circle. This is another important things. For example, I am creating a circle by using these different coordinate points, but can I calculate the center of the circle automatically on the fly? Because ultimately I will not store this information in database. This will be unnecessary storage into the system. So if this kind of provision is there, like the observer function, so I can observe or I can calculate any values by using any functions or front-end tools. So these are this is another important requirement what we required. Due to these special characteristics and specific query requirement, a standard database management system may not be sufficient for storage and management of spatial data. However, many industry standards RDBMS packages are now supporting spatial object inside RDBMS. So in relational database management system, whatever standard data types are there, these data types are not sufficient to handle your raster and vector data. So you require the additional power, and that power is known as a object oriented database management system, or I can say it is a ORDBMS. Sometimes we also call spatial database management system. But these days most of the your standard DBMS or RDBMS like MySQL, like PostgreSQL, Oracle, in fact 10G onward, all are supporting this kind of object orientation inside database management system. When I say the object orientation in database, it is slightly different than your object orientation in the programming. So object orientation in database means I can create my own object, I can define my data structure, but also I can define that the operation that can be performed on this data structure. So if this facility is available in any database management system or relational database management system, then I can say it is a ORDBMS, and it is a best suitable for my best vector and raster data. This is all about the basic understanding of database system, because when you are going to write a programs or you are going to perform a geocomputation processes for your data set, first you have to understand where is my data, and when I am storing this data, how I am going to store this data. So these are the basic characteristics, and these things are available in standard database system these days, as I told you. Now I will not go in detail of this vector and raster data, because it is already discussed in the last module, in the GIS data modules, where we discuss about what is vectors, what is rasters. In the vector data model, it is basically you are using three geometries, point, line and polygon, to represent your geographical features. In the raster data model, you use the picture element or pixel to represent the geographical features. So these are the two data models, and both the data models are having their own advantages and disadvantages. So in these things, pros and cons, when you have both in place, then you can decide which data model is best for your own studies, and based on this you can design your database system, and you can store your data into either in the database management system or maybe in a standard file based system. So already examples are there. Which model is suitable for storing what kind of informations. For examples, there are two kind of data things requirements will be there. One is a continuous data, and second is a discrete data. So based on the data type, data structure and nature of the data, you can decide the data models. So but any geographical features can be stored by using either of the data model, either this vector or raster model. You can use either one, absolutely no problems. But you have to choose, or when you are choosing the data model, you have to very clear either this model is going to achieve the objective of your project or not. Because when you are having the raster data, there will be a lot of this uncertainty in the boundaries. If you are clear-cut boundaries are not required, in that case the people are going for the raster data models, where we required a very discrete kind of environments. So that time we are going through the vector data models. But ultimately the picture elements or pixels are basically a cell or square elements, where the values are fixed within this cell, and then based on this value, cell values or digital numbers, we basically analyze this data and process this data for information extraction. So when you are dealing with the data that is a geodata, so you have to keep in mind these are the four important parameters. Already we discussed about these parameters in our GIS modules: projection, scale, accuracy and resolution. These are the very important point what you have to keep in mind. Projection is a method by which the curved 3D surface of the earth is represented by x and y coordinate in the 2D flat maps or a screen, and here distortion will be there in this kind of transformation from the 3D to 2D. So basically your earth is a 3D, and by applying the projection system you can convert the 3D earth system into the 2D maps. So this is a method. This method is already available, and today hundreds or thousands of projection systems are available. This is a mathematical approach. By applying this, basically we have to minimize the distortion in the database, and then we can prepare our data set. The second is a scale, the ratio of distance on a map to the equivalent distance on the ground. This is a simple is a ratio, and this ratio is very much required, especially when you are printing your maps in a topo sheet or in the form of the some printable maps or like a atlas. Accuracy is how well does the database information match the real world. So in the case of accuracy, we discuss about the positional accuracy, consistency, and completeness of the data. These are the very important three characteristics or component of the accuracy that you have to keep in mind. And of course, the resolutions, where we discuss about the 4 type of resolutions. One is a spatial resolution, which talk about the size of the smaller features able to recognize by the sensors, by the sensor system. So here another is a spectral, radiometric, and temporal. These are the 4 type of resolutions what we discuss are very much important or are required to assess the accuracy or the quality of your data in the GIS or geographic domain. Now, next important point what we have to understand in the geocomputation is called geomodeling. So you know that model is a abstract representation of the reality. So whatever we are seeing in the real world, if I am converting this reality into abstract form into my computer system, then you can say it is a model. So for example, we discuss about the raster and data model. When we are talking about data models, raster and vector 2 data models are in place. But in case of geomodeling, the spatial model basically a model of some process operation in space and time. There is a variation across the space and through time. Location is important here. The result of modeling changes when location changes, and location must be known. Here when I say geomodeling, that means these are the location specific models. So when I talk about the data model, that are totally different issue. But here in this case, you are basically developing a location specific models. That is, you are trying to understand the representation in the form of the abstract. So when you are generating the abstract representation of the reality, and here you can use some mathematical approach, like similarly we use in case of vector and raster data model, we have seen that different geometries are there. Similarly for spatial models, here these are the processes where basically we'll be considering the space and time together to understand the different geographical phenomena. The scale and digital model don't have scale factors because I told you about the scale, which is very important for the printable map. But when you have the digital data models, in the case of digital data, the scale is not considered, but they operate at the limited spatial resolution. So here more focus is given to the resolution. The spatial resolution is a critical factors. It determines what is left out of the model, the cost of the collecting data and the running of the models. It contributes to the model's accuracy, the degree of uncertainty about the real world created by the model. And the temporal resolution is important for the same reason, because suppose things are changing in due course of time, to understand the trend, to understand the patterns on a particular changing phenomena, that time the temporal resolution is very much required. So now the next question is, which technique will be appropriate for me, either data analysis or data modeling? So basically analysis is a static one point in a time, and searching of a patterns, anomalies, it help you generating ideas and hypotheses. It can help you for evaluation purpose, but modeling will be always a dynamic. So modeling are a dynamic natures. It is a multiple point in time, implementing ideas and hypotheses to compare to the real world. So modeling will help you to basically to understand the present scenario and also to do the future scenarios. You can generate the scenarios by using the modeling technique, and here you will be doing lot of experiment with the scenarios, and which scenario will be best. Here you will apply the decision making techniques, decision alternatives, and then you will be doing a lot of the statistical analysis here. Then you will be choosing the best alternative from the all the available things. So here this modeling will be dynamic in natures, and here it will also allow you to compare your outcome with the real world problems, and also it will help you to generate the scenarios. And the another important terminology what you have to understand is called modeling and simulations. So modeling is the act of building a model, and simulation is the process of using a model to study the behavior and performance of the actual theoretical system. So there are two important terminology generally in geocomputation will be using is called modeling and simulation. You know that modeling already we discussed about, but the simulation is the process of using a model to study the behavior and performance of an actual theoretical system. While a model aims to be true to the system it represents, a simulation can use model to explore a state that would not be possible in the original system. So model, three type of models we have. One is called physical model, second called process model, and third is called mathematical model. In case of simulation, we have three type of simulation. One is called live simulations, second is called virtual simulation, and third is a constructive simulation. So now I hope you are understanding the difference between the model and simulation. Ultimately, the simulations are using the models, because by using the models we can generate the simulation, and these are the example of the simulation. And in case of geocomputations, what kind of methods are available for different type of modeling and simulation activities? If you talk about geosimulations, then we have the cellular automata and agent-based modeling. For artificial intelligence and machine learning techniques are in place. Artificial neural networks, the evolutionary computing like EC, automatic zoning or ridge destructing. We have the cluster hunting. We have the interactive data mining tools. We have the visualization tool like a 2D and 3D visualizations. Very interactive systems are in place. Advanced raster processing techniques are available. Then we have the some mathematical techniques for the data analytics with respect to raster and vector data, and so on. There are so many techniques available for the geocomputation method. These are the few more popular techniques what I have listed in my presentation, and I hope it will be sometime useful for you during this course also, how this technique can be utilized for different type activities of geocomputations. Now, why it is required? Why this geocomputation is required? Why we are talking about these complex data analytics system? You know that today the not only in GIS domain but in all the sectors you must be seeing that there is an explosion of data. Lot of data is available, and these data sets, for example, around we create around 2.5 quintillion of data every day. Data comes in the various sources and has different format, and this enormous collection of data, sometimes we are referring it as a big data. So big data, this terminology you must be hearing these days, but the same is very much applicable in the GIS domain. And I can say GIS is one of the a very prominent and active user of big data. If you qualify, if you define the characteristic of the geospatial data what available today in the different format or different forms, so definitely it will qualify under the big data analytics. So here this explosion of data, lot of data is coming out, and another typical example you can understand how and what direction we are basically in this era. In 2020 people have created around 1.7 MB of data every second. The amount of data in the world was estimated about 44 gigabyte at down in 2020. By 2025, what we are expecting, the amount of data generated each day is expected to around 463 exabyte globally. Now you can think about what kind of data we are generating, and Google, Facebook, Microsoft, Amazon store around 1200 petabyte of information in their data centers. The world spend around almost $1 million per minute on commodities on the internet, and electronics art process roughly around 50 terabyte of data every day. And by 2025, what we are expecting, there would be around 75 billion Internet of Things or IoT devices in the world. Now you can think 75 billion IoT devices, you can think how much data they are going to create. So these devices will definitely be including some of the sensors, and these sensors are location, sometimes will be location specific sensor as well. So now a lot of data is available. In future we are expecting that this data will be part of our own GIS domain. So then by 2030 what we are expecting, 9 out of every 10 people age 6 and above would be digitally active. So this is the requirement, or this is the future of this huge amount of data repositories. That's why the very complex or advanced computation techniques are very much required. So here a term called big data. In GIS also we use this terminology very much, and here this big data having the characteristics like the huge amount of data in the with respect called the volume, then we have the variety, we have the value, velocity, and veracity. These are the 6 major characteristics of this big data, which we are handling in geographic domain as well. And here when I say that volume, of course, this is one of the characteristics. It is not all. Sometimes people say that if I have the large amount of data set, it will be big data. No, it is not like that. The big data is having different type of characteristics, and here the different formats of data for various sources, and the what kind of information, what kind of values you are able to extract from this particular data is another characteristics, and how quickly, how frequently this data is being updated, that is called under the velocity. If there is a lot of inconsistency or uncertainties in this data, then veracity is another important characteristic, which is very much important or applicable in the social media platforms, where you are generating lot of geographical data, lot of location specific data, but it also have lot of uncertainty in this database. So these are the 6 major characteristics of the big data. But for which what you have to understand is volume, velocity, variety, and veracity. These are the 4 important characteristics with respect to GIS, which are very much required. And before applying any geocomputation technique, that you have to understand very clearly. Then only you can build a appropriate algorithm or processes for handling this data, this huge amount of data sets. So here this is well known already. I discussed about it, how quickly this data is being updated. So here sensors, either it is a space-based sensor or ground-based sensors, are playing very, very important role. But same time, you know that the social media platforms, the crowdsourcing, the participatory GIS are also equally important to basically to increase the speed of data updation into our database system. So here the real-time data or fast data is coming from social media and networks, scientific instruments. You know that we are placing lot of sensors in the ground, or maybe satellite itself. If you take the example of very advanced satellite like a GIS set, where we are expecting the data every 15 minutes is going to update from the satellite sensors. So this kind of scientific instrument, either space or ground-based sensors, are basically collecting all sort of data, and mobile devices are playing another important role to get the data. You know that there are a number of applications like a FASTag, you may be knowing about it, we knowing about these IoT sensors, and these all data sets are becoming a part of our database system. And sometime if it is a structured data, we store into the DBMS or RDBMS. If it is unstructured data, we are going for the a different type of data management platforms like NoSQL platforms using HBase or MongoDB kind of platforms. So in this case, from the space-based sensors also, you know that a lot of data is being generated these days. If you see a very brief summary about around 6,542 satellites are orbiting the Earth as of January 1, 2021. You can think around 6,542 satellites are there in orbit, and out of which around 3,372 satellites are active. Now you can think how much data they are generating and how much data they are sending back to our Earth. So this is just I'm making a background why these geocomputation techniques are required. So that's why you can understand the space-based sensor or ground-based sensors are one of the very, very important source of data, and they are providing this huge amount of data repositories to our data centers or through Earth station and all. And these are the different type of satellite, the plenty of data from space. I have taken the few examples from the different type of satellites, right from the INSAT 3DR from ISRO. We have the OceanSat, ARISAT, SOSAT-2, Cartosat, and there are so many. Not only from ISRO, but other space agencies are also basically launching their own satellite, and these satellites are basically sending data on different resolutions, different like a spatial resolution, temporal resolution, spectral, and also with different radiometric resolution. So I'm not going to detail how the spatial and temporal resolution is important, especially for the geocomputation techniques, because our data is changing with respect to time. What you have to understand here, because when you are applying the geocomputation technique with this data, you have to understand that whatever you are studying today, maybe after 10 days or 15 days or 1 year or 2 year time period, the things will totally change. So in that case, the time series or temporal analysis will be very much important. In that case, you have to understand what kind of application you can build on top of these data sets. So there are many challenges here. One is how we storing the unprecedented volume of data, describing what we have, like metadata creation also will be very much required here. Finding what user need, because when we have such amount of data volume with us, so what is the user's requirement, that will be very much required here. Identify unwanted data or data which can be easily created or demand. Data information quality strategies, you require to create successful tools and languages to describe and find data so that reuse actively is encouraged here. Enable the real-time analysis of data, historical data for change analysis studies, and data information security, another important aspect, because when you have this kind of data in place in geocomputation or Geo-web services solutions, so data security also plays a very, very important role. Although all these topics we will not able to cover in this course, but you have to understand these are the important challenge when you are dealing with the geographical data or big geodata. When you do the analytics, basically we are doing four type of data analytics using the geocomputation techniques. One is called descriptive analysis, second called diagnostic analysis, third is called predictive analysis, and fourth is called prescriptive analysis. So these are the four type of analytics you can perform by using the geocomputation tools and techniques and on top of this geodata sets. So when you are harnessing this data by using geocomputation techniques, these are the popular techniques like OLTP. You may be knowing about online transaction processing in a database management system. We have the online analytical processing for what we are applying on the data warehousing. We know that when data is converted as a data warehouse, then the planners and decision makers can apply the OLAP techniques to understand the patterns, to understand the trend, for business analytics purpose. And these topics are are available in the at least in the graduation level for the BTech students. So where the OLTP and OLS systems are discussed well. But here in this kind of data, when we are having the real-time data or near real-time data from the sensors, either sensors are from the ground-based sensor or space-based sensors, we use RTAP, that is a real-time analytical processing. We call it for a big data architecture and technologies, and that is very much required here. And today, after 2010 onward, we are seeing a lot of research is going on this RTAP techniques. And here, these data sets are not always a textual data or numerical data, and these data set could be your video data or multimedia data as well. So these techniques are very much required to understand the data. And in these platforms, there are a number of tools available, software tools. In fact, from the open source community, most of the tools are there from the Apache projects, like HBase. Apache HBase is one of the very, very powerful NoSQL database. We have the real-time data processing using Apache Spark. We have the software integration platform like Talent. We have the Splunk for log analysis platforms. For data warehousing, the platform solutions like Hive. We have the messaging system like Kafka. We have the data storage and processing platform like Hadoop. Very interesting platform basically for Hadoop file systems, or which is working in the distributed file system, are very much required for handling the big data. And then we have the data analytics platform. Basically, these are if you combine all together, then you can provide the complete solution for your geocomputation requirement, what you can perform on this big geodata. If you talk about the geospatial enable projects from Apache, I have taken some of the example here. We have the spatial Hadoop. Hadoop is basically for distributed file system. We have the GeoTrails, like a geographic data processing engine for high performance applications. We have GeoMesa, which is store the index, query, and transform spatio-temporal data at a scale in HBase, Accumulo. And there are number of tools which are available under this project called GeoMesa. And then we have the software library, basically called Geo-web, and which is for distributed computing framework, where you can develop a lot of scientific models, scientific data analytics techniques on top of the Geo-web libraries. So these are some of the product which you can take for your geocomputation requirement on top of this big geodata. So how basically we store this data into, this is a typical example in case of, this is a typical example of Hadoop. I told you in the Hadoop platforms we have called Hadoop distributed file system, or we call it a SDF. Here you know that very interesting data models are defined. This is like we are dividing the data into the multiple chunks. For example, it is shown here in the 3 compute node. A and B is available in compute node 1, A and C is available in compute node 2, and C and B available in compute node 3. So here you can see that there is no chance of failure if one compute node is going down, but still your data will be intact. This way the data structure is designed. So when you are distributing your chunk in multiple compute nodes, so you can it can process this data very easily, and after the processing of this data, the data will be transferred to the master node, and then master node will be combining all these output together and then handing over result to the users. So here the idea is how this complex data processing can be performed, and you can further go to the literature of the Apache Hadoop, very interesting data models. So where the geocomputation technique can be can be implemented very easily by using the special Hadoop concept, and this is a very interesting thing. In these things there is something called map reduce. So there is technique called map reduce in Hadoop, where the data processings, one is a data storage, second is data processing. So when you do the data processing, that the similar approach is used. You divide your processes in multiple compute nodes, and then you process complete algorithm on this huge amount of data sets, and this technique is called as a map reduce, and very popular in a very scientific data modeling, especially for geocomputation technique development. There are a number of challenges in GIS. Most of the challenge already I discussed about it. I can skip this slide. Now you can understand who is the user of this data. You know that why I am doing this, so much analysis, so much data analytics or geocomputation on these data sets. You know that GIS, you can use this data set in number of applications like healthcare and research, automotive and productions, bank, insurance and physical models, telecom sectors, media, energy and utilities. There are a number of applications where this kind of big geodata applications, by applying the geocomputation technique, can be utilized, so that you can develop a very innovative applications for your users. This is a last one almost for this particular topic. How it works actually. It is basically GIS, as I told you in beginning itself, it is one of the very good example of the big data. So here number of GIS tools search, sift and sieve data from the multiple and disparate databases to organize it for better workflow and spatial analysis. And GIS runs operations that aggregate terabyte and more of spatial information, run analysis and visualize result as map. All this occurs in near real time or real time, with multiple data streaming into the existing GIS for better understanding of spatial trend and relationship. So these are the typical examples or basic characteristic where you can see that GIS is one of the basically GIS works with the big data, and the number of applications can be built by using this data set. Now the next question is, when I have this kind of data in place, I have the technique in place, I have geocomputation models and simulation technique in place, then when I'm presenting this data to the users, definitely today we are talking about the online computations. So everything has to be available in the client server platforms. So in this case, we use a concept of online GIS or Geo-web services, and this concept is used to serve the users or to serve the outcome of geocomputation technique of big data analytics. Here a typical architecture, already you may be knowing about it. In the background will be data, we'll have the database, in between we'll have the application servers, and then we'll be processing this data and presenting to the users. So this is a typical architectures where network based GIS system works. Here when I say the database server, it is not a standard database. Today we have the geocomputation technique, we have the big data analytics, we have the structured and unstructured data. So then you need a application servers, you need a GIS servers, and then you can serve, or you can take the request from the users and you can serve to the user back to the users by using these network based geo information services. Here presently we utilize a technique called Web 2.0, so which makes it more interactive, where in the background the extensive Markov language, RSS feed, JavaScript, AJAX, all these techniques are used. In front end, we use the web as a platforms, participatory approach, content syndications, web services, API to the users, so that very easily the data will be accessible and data can be analyzed on the fly. It's not necessary that to perform all these analytics you need a high-end computer system. No. Today, if you are utilizing the power of Web 2.0, you are utilizing the power of online GIS or cloud computation GIS, then you can build your own application on top of it. So we use here a very interesting data model, or we call it a service-oriented architectures called SOA. So this is very popular in the distributed web applications or distributed web computing platforms. So here service consumer, service broker and service providers are defined, and each one has their own role to play. So basically whatever data is published or hosted by the service providers, it is hosted as a web service or API in the service registry. Through the service registry, the consumers are accessing where the data is found there in the service registry. Then connectivity between the provider and service consumers are established. In GIS, we have very well structured SOA architecture for geospatial data. It is published by Open Geospatial Consortium. Since time is not permitting me, so I will not go in detail, but here you have to understand here the raster data, vector data, and then data processing. So web processing, web data services, these standards are available. You can publish your data as a XML based services or as a API, and same way you can also publish your processes or algorithm or geocomputation technique as a web processing services. This is a organization called Open Geospatial Consortium supporting all these activities of online computation or online geocomputations. So here they have around more than 50 web service standards published by OGC, and many the software developers of the open source or commercial softwares are basically following their standard for making their data interoperable for different type of application platforms or programming languages or software development platforms. These are some top popular service standard like catalog services, processing services, encoding services, data services, portal services, and other services. So that's all from my side today. I hope this session will be useful for you. It was just an introduction about these techniques, but in coming sessions we'll be discussing more in more details about all these things. But here you have to understand one point is data, how we are storing the data. I talk about the object orientations. Then when you have this data, then additional structure and unstructured data is becoming the part of this database system. Then this data is becoming the big data. So when it is a big data, then what kind of geocomputation technique will be useful? What kind of tools are available today? And we discuss about the different Apache products and how they can help you to do different type of computation requirements. Then we understand how the space-based data sets are basically providing input for this complex big data or big geodata sets. So then techniques, applications, and finally we see how these geocomputation techniques or systems are being developed by using the open platforms, where we have seen the service-oriented architectures in general, then OGC specific service standards, and now in the coming sessions we'll be discussing more about the technical things and more practical demonstration we'll be seeing here. So with this I conclude my session here. I welcome all of you to post your questions for discussion purpose. I will take a 2-minute break, then I will come back for the interactive session. Thank you very much.